Hey everyone, in this video I'm going to show you how I turned this unfinished corner of my basement into a fully finished space for my new workshop. There were a few major obstacles I had to overcome along the way. What do I do? It's literally, you can see the water moving, pouring down this crack. But I managed to pull it off and convert what was basically a dungeon into a space that's a joy to spend time in. As a quick disclaimer, I am not a professional contractor or an expert in finishing basements. I did do a lot of research about each step of this project, but I am positive there is room for improvement in much of what I did. Please, if you know more than I do about anything you see in this video, leave a comment down below or upvote other comments which you agree with. If you're a DIYer wanting to learn how to finish your own basement, I would recommend watching this video, then reading the comments before starting your own project. The first step in finishing any basement is fully understanding how dry the room is. I did this by taping some plastic to the wall and waiting a week. No condensation built up underneath it, so I knew the basement was dry. According to the research I did around insulating spaces like this, the best option in my area is to use 2-inch thick foam board directly against the concrete walls. However, this room is already a little smaller than I would want for a workshop, so instead I went with a 1/4-inch foam plus fiberglass insulation. The 1/4-inch foam basically doesn't provide any real R-valued insulation, but it'll keep the untreated studs from touching the concrete, and it forms a decent vapor barrier when the seams are taped properly. Another good option is spray-in closed-cell foam, which I didn't want to try to do myself, and I got quotes to do it from professionals that would have doubled the cost of the project, and I just couldn't afford it. Next up is framing. I spaced the 2x4 studs 16 inches on center wherever possible, and I used pressure-treated 2x4s for the base plates, which is important because they're in direct contact with concrete and they're the most likely to get damp. I framed around the 2 small windows in the room, left an opening for a door, and added 1 additional wall to hide a massive oil tank in the corner of the room. One issue I had with the vertical studs is that I bought 8-foot lengths and had to cut off a full foot out of each one since the ceiling is only 7 feet tall. I did save the scraps and was able to use most of them in corners as extra material to screw drywall into. I purchased this lumber at pretty much the worst possible time in the pandemic, and I paid a whopping $10 per stud. As I'm recording this video now, they are thankfully back down to around $3. I used a chalk line to help keep separate wall sections straight, and I secured them to the floor with concrete anchors. A good tip if you aren't stick framing the walls in place is to make them a 1/4 inch shorter than the ceiling to help tilt them into place easily and leave some wiggle room for slight adjustments to make everything square and plumb. Once they're in place, you can shim the top gap and nail them to the floor joists above. At this point, the framing is done. If you're paying attention, you might notice that there are actually electrical outlets installed at this point too, and I have to admit that this is the one part of the project I didn't do myself. I'm actually pretty confident with wiring and would have done it myself, but I was having other electric work done on my house at the same time, and the electrician gave me a really good deal to add these outlets while he was here and include them on the permit for the other work he was doing, so I pulled the trigger. He added a handful of 110 volt outlets and 3 220 outlets in the room. Next up is fiberglass insulation. If the studs are spaced properly, this is really quick and easy. It's just a matter of gently pressing the insulation between the studs and cutting out sections around outlets and windows. Now it's time to pay some attention to this ceiling. So the room directly above this one is actually a quiet family room space with a tile floor, and obviously power tools can be super loud. I did a ton of research on soundproofing ceilings, and there are a lot of great resources out there. Given my limited budget, I had to do my best to pick which options would give me the most bang for the buck. I ended up deciding to use resilient channel, which is sometimes called Z channel, to decouple the ceiling drywall from the joists above, combined with a single layer of 5/8 thick drywall. I initially hoped that the fiberglass insulation, which was already in the ceiling, would help a bit too, but I ended up changing my mind about that. More on that in a minute. I searched and searched for resilient channel and couldn't find any near me. The closest thing I could find was hat channel. I hoped that by attaching only one side of the hat channel to the ceiling, that I would have a small amount of flex and it would work a bit like resilient channel. I ended up mostly doing this, but in some places I attached it on both sides. I later asked about this on some online forums, and some people seemed to think that it was a bad idea and that it wouldn't behave like resilient channel at all. I actually installed most of the hat channel before changing my mind and deciding to spend a bit more money on special insulation dedicated to soundproofing. It's called Safe and Sound rock wool insulation. It's way more dense and heavy than fiberglass insulation and especially designed to absorb sound. I took the hat channel back off the ceiling and pressed the rock wool in place. I decided to leave the fiberglass in there as a second layer, though it might actually have been better to take it out and leave an air gap in there instead. Anyway, spoiler alert, the ceiling ended up super soundproof, so I regret nothing. Next, I laid out where I wanted the recessed ceiling lights to go. The lights are actually wafers and aren't much thicker than the drywall itself, so with the hat channel or other strapping, you can put them pretty much wherever you want. I decided to go with 16 lights for this 320 square foot room, which is frankly way more than you need. I overdid it because since I film down here, it's useful for me to have a ton of light. If this weren't going to be used as a film studio, I might have gone with 10 or 12 lights instead. I ran Romex past all the light spots and prayed I wouldn't forget where I put it once I closed up the ceiling with the drywall. One annoying part of this room is the massive beam going through the center of the ceiling held up by a lally column. If I weren't concerned with soundproofing, I would have just screwed drywall directly onto the beam, but instead I built a soffit around the beam and attached hat channel to it. To be honest, I'm pretty sure this won't make any difference, since noise can still travel straight up the pole into the beam and then into the floor joists above, but doing this way made sense to me at the time, so I went with it. Next, my wife and I spent a day renting a truck, buying 2,000 pounds of drywall, loading it onto the truck, driving it home, unloading it, then returning the truck. If you learn one lesson from this video, let it be this: get your drywall delivered. If you learn a second lesson from this video, it should be that you should rent a drywall lift. This thing was a lifesaver, especially since the drywall I used on the ceiling was 5/8 thick, which weighs in at a whopping 70 pounds a sheet. With this, you can effortlessly lift the drywall and move it around wherever you want and get it in the exact right place before you screw it in. I highly recommend it. When attaching the drywall to the ceiling, I used fine thread screws since I'm attaching it to the metal hat channel. I also made sure to only screw it into sections of the hat channel between the floor joists above. If you accidentally screw the drywall all the way into the joist above, that sort of defeats the whole purpose of using resilient channel, or in my case hat channel, to try to decouple the drywall from the joists. Next, I drilled the holes for the lights with a 6-inch hole saw. I could have waited to do this until later, but at this point I've been working in a super dark, uncomfortable room and I really wanted some light back in my life. Thankfully, my measurements were correct and all the holes I drilled ended up in the right places. I pulled through the Romex I had left for myself and wired up each of the lights. I connected up the switch and thankfully they all turned on the first try. Next, I hung the drywall on the walls. Here I used 1/2-inch drywall and used coarse thread screws since they're getting attached to wood studs. I used a drywall saw to cut out the holes around outlets. Here you can see the massive oil tank in the corner of the room. I built a permanent wall to the left of it, but I'm attaching OSB with screws on the front since the tank has to be accessible for filter changes and periodic maintenance. Right about now is when really hit the fan. At this point, there had been massive rain for several days straight, and when I came down to check on the room one morning, I found this. After panicking a bit more than I care to admit, I've removed the drywall and the framing and found the source of the leak. So this room is actually an addition to the house that was added about 30 years ago with its own separate poured concrete foundation. The leak is coming from the seam where the new foundation wall butts up against the existing. This is actually the only time I've ever seen any water in this room, and in retrospect, it's great that it happened before I finished taping, mudding, and painting the drywall. From the research I've done, the only way to really properly fix a basement leak is to fix the problem at its source. This usually means regrading the land around your house, fixing gutters, and sometimes digging down next to the foundation and sealing it from the outside. In my case, it turns out that only a few weeks before this, one of the gutters on the side of my house got disconnected, which resulted in water pouring straight down and pooling directly where this leak happened. Luckily, fixing the gutter was super easy and now there are no standing water issues. Regardless, I decided to be extra safe and put a layer of hydraulic cement over the crack. Again, with the gutter issue fixed, I don't think this is needed, but I felt that it couldn't hurt. I framed the wall back up using some plastic to serve as a vapor barrier since I had removed the foam to fix the leak, and then I started taping the drywall. I won't go into too much technical detail about the drywall process because it's a little boring, but I do want to share some of my thoughts. The first is that I tried out this tool called the Tape Buddy to help me with the taping, and I really liked it. It applies just the right amount of mud to the tape and makes it a lot easier for a beginner drywaller like myself. Of course, the pros have better, more efficient tools and techniques, but for a few bucks on Amazon, I'm glad I bought it. The second is that I want to recommend the YouTube channel called The Vancouver Carpenter. I had no interest in doing drywall at all until I started watching his videos, and he taught me everything I know. There's something oddly satisfying about watching experienced drywallers. At this point, I finally got around to installing the door. I went with a pre-hung solid core door for the soundproofing qualities and for the ease of installation. I bought the widest possible door I could fit since I'm planning to wheel lots of heavy power tools and carry lots of large pieces of furniture through this opening in the future. When I framed the rough opening for the door, I planned to leave a 1/4 inch on all sides so that I could easily shim the door frame into place. When the time came to actually install the door, somehow the opening ended up being about 1/8 of an inch too narrow. I'm not sure how that happened, but the only solution I could think of was to hack away at one of the studs with a chisel until the door fit. It was pretty messy, but it'll end up covered by trim anyway. I think if I were to do it again, I would remove the stud, run it through the planer a few times to take off the excess, and reinstall it. Next, I focused on covering up the elephant in the room, the big nasty oil tank. I used 2 sheets of OSB as a temporary wall attached with a few screws. I'll have to remove the lower panel about once a year for tank maintenance, but that shouldn't be too bad. Then I got back to work on the drywall. In the end, I used 2 top coats on the butt and factory joints, 1 coat on the inside corners, and paper-faced corner beads everywhere except the windows and the oil tank wall, where I used metal corner beads. I used a hawk and trowel for most of the work, but I used a 14-inch knife for the top coat, which I found especially useful on the butt joints, which I had to float out pretty wide in some areas. I used a manual pole sander, which actually wasn't too difficult because I spent a lot of time feathering my edges and generally being careful with my mudding. But a major drawback of hand sanding is the dust, which gets everywhere. Painting is particularly boring, so I'll gloss over that, but I used white paint on the ceiling, a light blue tinted paint on the walls, which I chose because I like the name, Solemn Silence, and I left the floor plain concrete. I did a lot of research into the various flooring options like painting the concrete, epoxy coating it, laminate flooring, proper hardwood flooring, and a bunch of others, and I couldn't make up my mind. I think untreated concrete is honestly not a great option because any paint or finish spilled on the floor is going to be a big pain to clean up. My plan for now is to cover most of the floor in foam or rubber tiles to make standing more comfortable, and perhaps one day in the future lay down a proper subfloor or flooring system. For some reason, I thought to cover the concrete floors before painting, but I didn't think to cover them before mudding the drywall. It took quite a bit of scraping and mopping to clean up all the spilled drywall mud. The last step is the baseboard and window trim. One neat trick for this is that you can use a magnet to find a stud because they'll be attracted to the drywall screws or nails. When attaching the baseboard, I first found one stud with a magnet, then nailed the baseboard every 16 inches after that. I used some L-shaped trim to cover the awkward corner of the oil tank OSB wall, and I used my scrub plane to roughly scribe the baseboard to the floor in places where the concrete was a little uneven. For the window and door trim, I used a method I learned from the Vancouver carpenter. I built the entire trim frame on my workbench, attaching the corners with some CA glue and spray-on accelerant. The glue is surprisingly strong, and it only has to hold long enough to nail the frame on the wall. After a few quick beads of caulk and paint on the baseboard and trim, the room is done. And here's what it looks like with most of my tools moved in. I had a blast finishing this basement space, and I can't wait to get back to filming furniture builds in here ASAP. I hope you enjoyed this video, and thanks to all of you who like, comment, and subscribe to my channel. And a special thanks to my Patreons for supporting me as well.